Hello everyone, let us look into this question. If x is equal to secant phi minus tan phi and y is equal to cosecant phi plus cot phi, show that xy plus x minus y plus 1 equal to 0. This is what we have to prove it. So let us take the LHS part, that is xy plus x minus y plus 1. Now we will substitute all the values of x and y here. So I will get this as secant phi minus tan phi into cosec phi plus cot phi plus secant phi minus tan phi minus of cosec phi plus cot phi plus 1. Now convert everything with respect to cos and sin. So this I can write it as 1 by cos phi minus sin phi by cos phi. Into this I can write this as 1 by sin phi plus cos phi by sin phi plus even this one I can write this as 1 by cos phi minus sin phi by cos phi minus of, it is 1 by sin phi plus cos phi by sin phi plus 1. Here we can take cos phi common in the denominator here. So I will get this as 1 minus sin phi by cos phi into, this will be 1 plus cos phi by sin phi. Okay, plus here if I take cos phi common in the denominator, I will get as 1 minus sin phi by cos phi. Okay, minus of 1 plus cos phi by sin phi plus 1. Right, now next step, these two gets multiplied and here we will take the LCM. I will get this as cos phi and sin phi. Okay, so next step, when these two terms gets multiplied, I will get it as 1 minus sin phi into 1 plus cos phi by cos phi sin phi. Right, plus here when I take the LCM, I will get this as cos phi sin phi. Okay, this sin phi will multiply with this. So I will get this as sin phi into 1 minus sin phi, right, minus cos phi into 1 plus cos phi, right, minus cos phi into 1 plus cos phi. This plus 1 is as it is. Now when you try to simplify the bracket terms, so here cos phi sin phi, it is there in the denominator. When I simplify this part, I will get it as 1 plus cos phi minus sin phi. Okay, so and this will be minus sin phi cos phi. Okay, plus, and here also it is cos phi sin phi. So this is, when you simplify this, I will get this as sin phi minus sin square phi minus cos phi minus cos square phi. Okay, plus 1 is as it is. Here cos phi sin phi, cos phi sin phi both are same in the denominator. So I can write all the terms at once. I'll write cos phi sin phi in the denominator. Okay. So combinedly when I write, I will try to adjust whatever the things are there with us. 1 plus cos phi minus sin phi minus sin phi cos phi, right? And this is plus sin phi, and I will write this minus cos phi here. And out of these two terms, I will take out minus common. I will get this as sin square phi plus cos square phi. And this plus 1 is as it is. Now if we check it out, the terms that can be cancelled, plus cos phi minus cos phi minus sin phi plus sin phi. Okay. So the next step of this will be, okay, I'll write in the next page. So when you go to the next page, this 1 and this in the place of this also I can write it as 1. So what I am left with here, 1 minus sin phi cos phi, okay, 1 minus sin phi cos phi minus of, instead of sin square phi plus cos square phi, I can write it as 1 by cos phi sin phi plus 1. So here I will be left with 1, this 1 and this 1 gets cancelled. I am left with only minus sin phi cos phi by cos phi sin phi plus 1. So this will be, these 2 gets cancelled. I am left with minus 1 plus 1. So final answer is 0. Right? Hence, the LHS part what we are taking here, the final answer of that will be equal to 0. That is what we have to prove it. Therefore, xy plus x minus y plus 1, that is equal to 0. This is what we have to prove it. Right? So I hope you got the solution here. We'll meet with the next question next time. Thank you.